Aloha Thursday, everybody. Here's your warm-up. You know the drill. Copy these down. Try them. If you get stuck, come back for hints. Or come back and see what all the answers are. Want to warn you on these shapes here, especially this one. Don't try to do this one in one step. This is a irregular figure. Some people call it complex figure. Break it into smaller pieces, and then it's easy. And I also want to remind you, same thing here. These are big, ugly, scary problems, but each piece of the problem is something you can do. Okay? Follow the rules of math. And the rules of math have to do with something called O.o.O. Anybody remember what O.o.O stands for? Order of operations. So pay attention to the order of operations. And again, what that is simply is which things do you do first in a big problem. Okay? All right, have at it. We'll see you in a little bit. I must have paused the song in the background to come in at the same time after you guys finished all that, right? Okay, what two numbers have a product of 63 and a sum of 16? 7 and 9. And how about a product of 42 and a sum of 13? 6 times 7 or 6 plus 7, right? How about 2 and 5 tenths and 5 and 5 tenths? Well, when I ignore the decimal, sometimes this helps. I'm thinking what multiplied by what equals 25, and the only thing I can think of is 5 times 5 or 25 times 1. When I say 5 times 5, I see this decimal here is a 5 and a 5, so maybe 5 and 5 tenths. And remember, when you multiply decimals, pretend there's no decimal. 5 times 5 is 25. Then figure out how many places you had to move the decimal so you could pretend there was no decimal. I didn't have to move anything here. Here I had to move it one spot. Right? Remember, the decimal on the right means you can ignore it, right? It's like it doesn't exist because $5 equals $5. Okay? So I had to move it one spot to get it over there where I can pretend, so I had to move the decimal back one spot into my answer, and that works. And when I go add 5 and 5 tenths, remember the rule when you add or subtract or compare is to line up those decimals. And the only tricky thing there is to make sure that you put the decimal to the right of whole numbers, okay? Before I add, I usually add zeros, make it come out to the same spot, and then it becomes easy. Okay, see how that worked? Okay, similar thing happens here. We have 7 and 7 tenths, and you can go double check those. Area and perimeter. Perimeter, remember I got to add, and when I'm adding decimals, got to line up the decimals. So 1 and 2 tenths and 0 and 6 tenths. But that only gets me halfway around. Okay, make sure you enclose the whole figure. So I have another 6 tenths, another 1 and 2 tenths. And the decimal comes straight down when I add. Forgot to bring that decimal down, 1, 1, 1. So I get 3 and 6 tenths centimeters. And to get the area of a rectangle, you're just going to multiply. So I'm pretending there's no decimal. 6 times 12, 6 dozen is 72. And then I realized I had to move it over one spot there and one spot there, so I got to go over 2 spots. So the area of this is actually 72 hundredths square centimeters. Okay. Here it's a square, so I can do 1.2, 1.2, 1.2, 1.2, or there's a shortcut. For square, you can do 4 times the side to get the perimeter. So the perimeter here is 4 times, I'm going to pretend it's 12. That's 4 dozen, 48. And then I'm going to go over, there was no decimal in the 4, right? I had to move it over one spot there, so move it over one spot in my answer. The perimeter is 4.8 centimeters. And the area, I'm going to pretend like it's 12 times 12. That's 144. That's what's called a gross number, a dozen. Teach you about that later. And this time I have 1.2 times 1.2, so I moved it over for each one. I got to go over 2 spots in my answer. So 1 and 44/100 square centimeters. Okay, complex figure, irregular figure. Don't try to eat this hamburger in one bite. Don't try to eat the burrito in one bite. Take a bite, chew, right? Enjoy it. Now, what does that mean? That means I'm going to take this in pieces. And the first piece is I'm missing 2 numbers. Okay? So I have to figure out what those numbers are. Now, I didn't draw this that great, as you can tell. But if this is 12 meters and this is 6 meters, what is left up here? Well, it's not drawn to scale, but that's another 6 meters, right? From here to here, because 6 and 6 makes. Okay? So if that's 6, this over here is going to be 6. Now this is 24 and this is 12. What's this part going to be? Well, this part was 12 and it has to be 20. That's also going to be 12. Okay, sorry for the bad drawing. I rushed. So now to get the perimeter, I'm doing 12 plus 12 plus 6 plus 12 plus 6 plus 24. Okay, so 24 and 12 is 36. Another 12 is 48. 6 is 54, and 12, 54 and 12 is 66 plus 6 more. I'm getting 72 meters for the perimeter. And to double check, I'm going to go the opposite way or do it differently, right? So I'll start here. 6 and 12 is 18, and 6 more is 24. I'm going to jump on that 24 because I'm going to double it. 24 and 24 is 48, and then 48 and 2 is 50, plus 10 more is 60. And 60 and 12 is, okay, so I trust myself on that one. Now, area, break it up into easy pieces, right? Let's make this square and get the area of that, and then the rectangle. 12 times 12 is a dozen, gross number, so that's 144 square meters. 6 times 12 is 6 tens, 60. 6 twos, 12, 60 and 12. 72. To get the area of the whole thing, I just put those together. 144 and 72. 216 square meters. How'd you do? Did you get it? Okay. We also could have made this a long rectangle and say 6 times 24, and this smaller rectangle 12 times 6. And again, 6 times 24 is going to be 144. 6 times 12, again, 72. I'd be adding the same numbers, getting the same answer. Okay, solve. These are O.o.O problems in order of operations. What comes first in order of operations? Takes cuts in front of everybody. The president. Or parentheses. You can draw them normal like that. You can draw them kind of fancy if you want. Or they can be the big giant brackets. But whatever it is, that takes cuts in front of everything in order of operations. What comes second is exponents. That's like your grandma, your abuelita. All right, you want to let her take cuts in front of everybody, and you'd let her go in front of the president, but they won't let you. All right. Now, after that, we have adding, subtracting, dividing, and multiplying, which is a little bit more sophisticated. Multiplying, dividing, right? That's the ladies first. The ladies are more sophisticated. We know that. Boys can be a little bit more goofy. In general, not always. My sister was a little bit more goofy than my brother. My brother's a little more serious. That's probably why I made him turn into a doctor. He got goofy sometimes, and he's more goofy than she is now. So multiplying and dividing, but I always write dividing and multiplying. Anybody know why I do dividing first? And you could do that backslash. You do the dot. The reason I do dividing and multiplying first, and I write it as subtracting and adding, is because I want to combat those that learn PEMDAS. Because PEMDAS works for the P and the E, parentheses and exponents, but MD, sometimes it's DM. It's just whatever comes up first goes first on this level. You do all multiplying and dividing before you do any adding, subtracting. All right, so what am I doing first? There's no parentheses here. But I have exponents, so let's get rid of those. 16 squared is not 32. 16 times 16. Good. And 2 to the third power is not 6. It's 2 times 2 times 2. It's the snowman. Now, what do I have left? I have subtracting and multiplying. What comes first? Well, the subtracting is lined up first, but I have to do all my multiplying before I do any adding and subtracting. 7 times 8 is 56. And I'm glad I did that first, because what's the difference between 256 and 56? 200. Okay? All right. Now I have big parentheses. I have this ugly, scary thing that makes me want to quit before I start. Okay? But I'm not going to, because I trust Mr. Daniel is not trying to trick me. Or maybe he is trying to trick me, but I trust Mr. Daniel says I can do this if I take it one step at a time. So the first step is parentheses. Inside that big set of parentheses, I have another set. So I'm going to go here first. And here I have adding and exponents. What comes first? The exponents. 6 to the second power is not 12, it's 6 times 6. 8 to the second power is not 16, it's 8 times 8. Fell on the floor, I picked it up. It was 64. And the sum of those two is 100. Now, why did I add before I subtracted? Because this was still in parentheses. So that whole thing comes down to 100. And 10 to the second power is not 20. It's 10 times 10. It's also 100. And what's the difference between 100 and 100? 0. And now I realize that that big ugly thing off to the right that I was afraid of and almost made me quit, it doesn't matter what that is, because I'm going to multiply it by 0. And when you multiply anything by 0, what do you get? Big fat donut. We don't like donuts in the grade book, but that made it easy, didn't it? Okay? Don't be afraid to try. Okay, same thing here. This might be one of those big, ugly, scary things you're afraid of, but what is it? It's the same thing over the same thing. Whenever you have the same number over another number in a fraction, like 8 over 8, right? Or 3 over 3, you know what it simplifies to. 8/8 is the same as 1 whole. 3/3 is the same as 1 whole. So whatever this is, you don't care, because it's the same thing over the same thing. That's 1. So you just have 1 plus 3 to the 4th power. You got to figure out what 3 to the 4th power is. That could be hard, right? Remember, that's not 12. It's 3 times 3 times 3 times 3. And I like to put these together and say that's the same as 9 times 9, which is 81. What's the sum of 1 and 81? All right, went a little fast today. Don't be afraid to pause. Don't be afraid to rewind. Go back and double check what I did, okay? You want to understand, and there's nothing wrong with rewinding and hearing something again. It's just like saying, can you repeat that, please? Okay? Good job.